And welcome to today's ECA Learning Zone webinar. Today we have a connected fire detection course from Hispec, which is delivered by Ryan Harding, who is the Learning and Development Manager at Hispec. So Ryan will be taking you through the course for the first part of the session, and then at the end we'll be answering your questions. So if you have any questions, please just put them into the chat box. This webinar is certified for 1 hour of CPD, and you can claim this certificate by filling in the form, which I'll drop into the chat box. And this session is being recorded, so it'll be available for you to watch on YouTube. So thank you for joining us, and over to you, Ryan.
Oh, hi, good afternoon. Welcome to everybody. So as Kat just mentioned, my name's Ryan. I'm the Learning and Development Manager for Hispec Life Safety and Housing Solutions. So the content itself will probably take around about 40 minutes, 45 minutes tops, to go through. And as Kat mentioned, it is actually certified for an hour of CPD. So we'll be sending a certificate to Kat to send it on to you guys when you fill out your form. As mentioned, any questions, just pop them into a chat window. And when we finish the training, I will answer any that we can. Any that I can't answer, I'll make a note of, and I'll get the answer and send it back to you via Kat. So good afternoon, everybody, and welcome to the Introduction to Life Safety Systems, Connected Fire and CO Detection by myself, Ryan Harding, from Hispec Life Safety and Housing Solutions. So before we begin, just a little bit about Hispec as a business. So Hispec as a company, we began in 2002, so 23 years this year in business. And how we work as a business, we use a target market approach, going to the contractor via the wholesale network with our goods, focusing in life safety and housing solutions. And by that, what we look at is domestic fire and CO protection with smokes, heats, carbon monoxide detectors, commercial fire alarms, and a range of our lighting, along with site lighting, air quality, and our emergency lighting offer as well. One of the key things we look at as a business is to actually have a focus on what we call value addition. So we look to basically make sure our prices are competitive, so that for the guys that are installing the goods on the tools, it makes it so for them, it's a product that they can actually purchase and use for their customer without being overly priced. All of the products that Hispec do are developed in-house. Our offices are up in Chorley, up in the northwest, and we develop and design all of our products in-house before sending those over for manufacturer. We also partner with various trade associations in the industry. So some of those you'll see on screen, which you can, I'm sure you have many times dealt with. So we are members of the LIA and the FIA, along with the FPA, and also the other ones that you see on screen there. We partner with these trade associations to keep on top of industry trends, and for us to be able to make sure that, any changes coming within the industry, we're able to actually update our customer base and contractors on keeping us up to the current regs and requirements when talking to the guys out there. So we'll start with the first question, which is, how do you define life safety, and what is a life safety system? So heavily regulated in the UK, it's imperative that landlords and property owners ensure they have the correct and relevant procedures in place to prevent the loss of life or serious injury. Now, life safety systems themselves, they're in place for one reason and one reason only. That is to save lives or prevent serious injury. So this doesn't just cover fire detection or emergency lighting, but more broadly, it's a system of aids that help the health and safety of a building and the building's occupants. And that can be done through prevention, detection, alerts, or a general reduction of risk. While it's impossible to eradicate the loss of life from emergency situations altogether, safety systems provide a means of protecting lives further. Different ways you can minimise potential loss of lives are the introduction of fire alarms, smoke detectors, heat detectors, also sprinkler systems, escape routes illuminated by emergency lighting, silent killers such as carbon monoxide. We can use carbon monoxide detectors to pick up that extremely harmful and silent killer. So when we talk about life safety systems and connected fire detection in a domestic premises, what we mean by connected premises is a bunch of alarms, and when one goes off, so does everyone else. So if we go back around about 15 years, maybe a little bit less, maybe a little bit more, we had one alarm generally in our domestic properties, which was that smoke alarm that was fitted in the hallway. And you're only really as good in a scenario like that as your instincts and the guarantee that you hear that alarm when it goes off, providing that alarm is working correctly. When it comes to interconnected fire detection, as per BS 5839 Part 6 regulations, it is a mains wired alarm with a battery backup interconnected via radio frequency or cable, meaning that when one alarm is triggered, the rest of the alarms in the building go off, giving the inhabitants of that building the best possible chance of escape or investigation. So why do we do that? Well, from the Government Incident Statistics Report back in 2023, it was found that there was over 39,000 building fires in the UK. The actual number was 39,045 building fires. And from that, there was in excess of 6,000 non-fatal casualties, with over 2,700 people requiring hospital treatment. From these fires, we still had 208 fire-related deaths, which I think everyone can agree that is far too many regarding fire-related preventable deaths through the means of adequate fire detection and protection. And we also requested the response time for the actual call out from the fire brigade from the point of call out to a domestic incident to arriving on scene. And the average time currently in the UK is 9 minutes. Now, I'm sure everyone can agree that 9 minutes of being in a burning building is a long time. So that connected fire detection gives you that best possible chance of getting out of that building before it's too late, protecting lives and preventing injury. So, as I mentioned, what are the British standards that govern fire detection in the UK? So, to explain the British standards in a little bit more detail, I'm going to play you a short video. A few of the team up in Chorley have put this video together, and it covers all that you're going to need to know about whether fire detection methods are required in both commercial and domestic properties, and that references to our BS 5839 Part 1 regs and requirements for commercial and BS 5839 Part 6 for domestic.
Will, take 2.
I'm ready to go.
Take 5.
Does that sound right?
Well,
Take 13.
you know what, I always thought I'd be good at this, but no chance.
BS 5839 Part 1 Fire Detection and Alarm Systems in Non-Domestic Premises. BS 5839 Part 1 is a British standard for fire detection and alarm systems in non-domestic premises. It provides guidelines for design, installation, commissioning and maintenance.
The significance of this standard lies in its ability to accommodate the diverse needs of different commercial premises.
Applicable to commercial buildings, industrial facilities and business places. Allows customisation of fire detection and alarm systems based on building size, activities and fire risk.
The example given illustrates this variability by comparing a simple system with just 2 manual call points and sounders to a more intricate setup involving addressable systems connected to various auxiliary devices, as well as the intercommunicating control and indicating panels.
In essence, BS 5839 Part 1 provides a framework that allows for the customisation of fire detection and alarm systems to suit the specific characteristics and requirements of different non-domestic premises, ensuring that the chosen system is both effective and proportionate to the level of risk in a given environment.
BS 5839-6 is a British standard that provides recommendations for the design, installation and commissioning of fire alarm and fire detection systems specifically tailored for domestic premises.
Unlike non-domestic premises, where BS 5839 Part 1 is applicable, domestic premises include homes, apartments and other residential buildings.
The standard acknowledges the diverse nature of domestic environments and offers flexibility in designing fire alarm and detection systems that suit varying conditions.
Systems include mains power detectors with backup batteries, interconnected via radio frequency or hardwired connections. Options for battery-powered devices suitable for situations where hardwiring is impractical.
This provides a wireless means of communication between the different components of the fire alarm system, offering a more adaptable solution for certain domestic settings.
The flexibility outlined in BS 5839 Part 6 recognises the importance of tailoring fire alarm and detection systems to the specific characteristics and constraints of residential spaces. By accommodating various configurations, the standard aims to ensure that fire safety measures in domestic premises are effective, reliable and well suited to the unique conditions of homes and residential buildings. Different types of detection methods: smoke, heat and carbon monoxide used in fire and safety systems, and it suggests their combination based on specific environmental conditions for enhanced safety.
Smoke detection. Smoke alarms are designed to detect the presence of smoke, which is an early indicator of potential fire. They are typically installed in living areas and hallways where the first signs of a fire are likely to be detected.
Heat detection. Heat alarms are sensitive to changes in temperature rather than smoke. They are particularly suitable for environments like kitchens, where the presence of smoke from cooking might trigger false alarms in traditional smoke detectors.
Carbon monoxide detection. Carbon monoxide is a colourless, odourless gas that can be produced by the incomplete combustion of fossil fuels. Carbon monoxide alarms are crucial in areas containing solid fuel burning appliances, examples fireplaces and wood burning stoves, to detect the presence of this potentially lethal gas.
The recommendation to combine these detection methods is based on optimising safety measures for specific environments. For instance, in a kitchen where smoke from cooking is common, a heat alarm may be more suitable to avoid false alarms. In living areas and hallways where early detection of a smouldering fire is crucial, smoke alarms are preferred.
Additionally, areas with solid fuel burning appliances like a fireplace may require carbon monoxide detection to prevent the build-up of this silent and potentially deadly gas.
By tailoring the types of detection to the specific characteristics of different areas within a building, one can create a comprehensive and effective safety system that addresses various potential risks.
So that covers the design, installation, commissioning and maintenance required for BS 5839 Part 6. However, what it doesn't answer is how do you decide what type of alarm is best suited for your type of property? Domestic dwellings require both a specific level of protection, referring to a number and position of the alarms in a property, and also a specific grade of detection to what the individual alarms offer. So that can be whether you're putting alarms in a rented property, HMO, sheltered housing, or a new build property which is going to be occupied by the homeowner. So as per BS 5839 Part 6, there are three types of basic categories of protection: LD3, LD2 and LD1. An LD3 category of protection requires fire alarms in escape routes only, so this is the minimum protection. In this situation, you will put an alarm in the hallway and the landing and any converted loft extension. Generally, this is going into an existing premises which is owner occupied, and that can be a bungalow, a flat, or a single story house-based house dwelling. And these alarms would require a minimum of a grade D2 category alarm. Now, a grade D2 category alarm in England is a mains powered interconnected smoke or heat alarm with a 9-volt replaceable battery. So in a homeowner property requiring minimum protection, mains powered with a replaceable battery is allowed. Our next category of protection we would look at would be the LD2 additional protection, commonly seen in new build properties where these are being built. And in this situation, you will be putting protection in all circulation spaces and high-risk rooms. So this would be areas, again, such as hallways and landings, but you would now be looking at putting specific protection in the living area, the kitchen for a heat alarm, and again, any loft extensions. The grade of alarm required will depend entirely on the occupants of the property. So if this property is a rental property, that would require a minimum of a grade D1 category alarm. Grade D1 being a mains wired interconnected alarm with a 10-year lithium sealed battery backup. Other new build properties which are owner occupied, they would require a minimum of grade D2, downgrading that battery backup from lithium 10-year sealed to 9-volt. However, a recommendation for LD2 is always, where possible, to fit a grade D1, because we aren't always aware that a new build property will be occupied by a homeowner or a buy-to-let rental property, or ultimately somebody purchasing the property with a view to potentially rent that out in the coming years, in which case providing a grade D1 protection at the start does, to a degree, future-proof that property. Finally, we have the LD1 maximum protection. So this is where you're going to be putting an alarm in all areas where a fire could start, commonly seen in HMOs. So alarms would be in areas such as hallways and landings, living spaces, heat alarms in kitchens, smoke alarms in all bedrooms, also air and meter cupboards where they will require areas of combustible material, i.e. boilers, immersion heaters, or potentially in older builds, consumer units. Also, loft extensions and attached garages would require this protection too. The only area not required would be bathrooms and shower rooms or toilets. In an LD1 category of protection, that would require a minimum of a grade D1 category system, mains wired, interconnected with a 10-year lithium sealed battery backup. So, when we talk about methods of connectivity, What do we mean? So there are a couple of key methods of connectivity into a domestic alarm setting, and they are generally either radio frequency or 9-volt cable interlink. In new build properties, it is preferred that the alarms are a radio frequency pairing. So that case, when the power is cut to the cable by accident, it doesn't remove the ability to communicate with the other alarms in the building, as the battery will kick in and a radio frequency will continue to talk to the alarms. So in these scenarios, it's just a standard wiring to line and neutral, and radio frequency pairing for an 868 megahertz frequency, communicating in a self-learned pairing with the other alarms in the property, so that when one alarm goes off, it sends that signal to trigger the other alarms. However, it is still under the regs available and allowed to install alarms and interlink these via the 9-volt cable interlink using the IC part of your alarm base, your interlinking cable area, where you have that cable interlinking to all alarms, sending that communication across the wire so that these alarms can trigger. For more commercial settings, you will probably look at Part 1 methods, and the type of properties that would be required would be more like your commercial areas, making it very difficult. So you generally will be looking at fire panels, conventional alarm panels, wiring your FP cable with zone style alerting. Examples of that would be bars, restaurants, or small installations. So commercial fire systems. Generally, when it comes to commercial fire systems, they can be wired either as a radial or as a loop, and that depends on the manufacturer's specifications and the system capabilities. Traditional radial systems wiring configurations normally will begin at the control panel and run down the zone with all the devices attached to the cable with an end of line resistor in the last device on the zone, signalling that that is the end of the line. These type of systems are a lot easier to install, but devices can't be individually identified or addressed within a panel. So normally when you get an alert, it will tell you have an issue in that zone. However, it will be down to the person to go and find where that issue is and which device is either faulty or picked up an incident. Loop wiring, however, sometimes also known as a ring circuit, they start and end at the fire alarm control panel. This type of wiring configuration is usually found in addressable systems, where each and every device needs to be individually monitored. These type of systems offer more functionality, but typically come at a larger cost due to the increased amount of fireproof cable required. The beauty of a system like the Hispec 2CAS is it can be wired either as a loop or a radial, meaning in most retrofit installations, systems will be wired as loop. Therefore, a retrofit 2CAS will reduce the installation costs as your same wiring can remain in place, whereas in a brand new installation, the system can be wired as radial to reduce the time installing and the money on the materials. The 2CAS system doesn't require a separate sounder circuit, so sounders themselves can actually be wired onto the same circuit as the detection devices and the call points. However, there is also within these type of panels a separate sounder circuit for use as and when required. So, is there a ultimate multi-purpose office space solution? So yeah, I did just mention the Hispec 2CAS system. So that type of system we look at is more of a hybrid style system, a 2-wire soft addressable conventional system, ideal for smaller installations. Working as a single loop 2-wire conventional alarm panel, it has the ability to soft address devices in small installations such as your detectors, call points, interfaces and sounders, and they can all be connected on that same addressable loop. One is a single loop panel. It has the option to allow the system to be wired as 2, 4 or 8 radial circuits. So this panel becomes very versatile for retrofit situations on the market. The feature can also be used for new installations where the layout of the building makes radial wiring more convenient than wiring as a loop. To go through a little bit of what these type of systems work like and how they perform, I'm just going to play you a small video with some highlights of some of the features and how they benefit both the contractor and the end user in creating a connected fire alarm system as per the Part 1 regulations.
Is a single loop 2-wire conventional alarm panel with the ability to soft address devices in smaller installations. 2CAS uses MK2 protocol, so can run any of our addressable devices. Detectors, call points, interfaces and sounders can all be connected to the same addressable loop. Designed with precision and expertise, our system is built to exceed industry standards, meeting the rigorous requirements of BS 58391 and BSEN 54. With soft addressable technology, pinpointing triggers and faults has never been easier. Our system streamlines identification and resolution, ensuring optimal safety and efficiency. From multiple occupancy housing to large commercial spaces, our system adapts to meet the unique needs of any environment. Whether it's a new installation or retrofitting existing infrastructure, our system offers unparalleled flexibility and ease of integration. The 2CAS single loop panel allows the system to be wired as a 2, 4 or 8 radial circuit. With our sandwich sounder device, enhancing sound coverage is simple and cost effective, ensuring comprehensive alerting without added complexity. Whether it's safeguarding lives or protecting property, our system is tailored to meet your specific needs. Choose from a range of configurations to suit your requirements. Experience the future of fast safety with Hispec's 2-wire conventional alarm system. Contact us today to learn more and secure your peace of mind. Your safety protected.
So one of the questions we get asked when it comes to the commercial fire system is, does it have the ability to interlink fire detection devices with individual apartment protection, commonly known as the grade A protection? And yes, it does. Through the addition of an input-output device, you can link your commercial system up to your domestic devices in kind of an apartment block protection, so that when the apartment alarms go off, they can send the connection and the signal to the commercial panel to set the alarm, and vice versa. When the commercial panel is activated, it can also send that detection to the individual flats for relevant escape or evacuation. So that particular part covers our part 6 and part 1 basic regs regarding the wiring and the interlinkability of domestic and some commercial smoke and fire and heat detectors. The next thing we're going to look at now is a little bit going into the avenue of carbon monoxide, or CO. And one of the key things is that many people out there don't actually know the dangers of carbon monoxide and what those symptoms are. So obviously some of the symptoms of carbon monoxide are quite common with other ailments: headaches, nausea, breathlessness, collapse, dizziness and loss of consciousness. So the result of this being that all symptoms that you would associate with other things: feeling a bit nauseous, something we've eaten, breathless, I'm a little bit out of shape, feeling dizzy, I've got up a little bit too fast, that funny headache that just doesn't go away. And many people don't think to just test that CO alarm, or have they even got a CO alarm installed in their property. Now, how do we stay safe with carbon monoxide present in properties? Well, the first thing we have to look at is making sure we have an audible alarm fitted near all fuel burning appliances, and that can be gas stoves, fireplaces, water heaters and cookers, and also things like log burning stoves that we are now seeing more and more in domestic properties. These devices must have a CO alarm fitted nearby to activate in the case of it sensing a CO leak, as the CO itself is silent killer. You can't taste it, you can't smell it, and you can't see it. The other key thing to do is to ensure that all the appliances are maintained and inspected annually where applicable. And we always tell people to test a CO detector often, and you should always give it a little vacuum round at least once a month to ensure that any dust hasn't got into the sensors, causing false alarms or faults in your device. So why is this so important? Well, 1 in 5 homeowners in the UK have never had a gas safety check, so they don't actually know whether or not their device itself is actually safe. And also there's over 200 non-fatal hospital admissions per year, all caused from CO poisoning. On average, 40 people die each year from accidental CO poisoning, and less than 20% of people would consider CO poisoning to be the cause of a headache that they were experiencing at home. One of the scary facts are that it's currently estimated to be over 5 million homes in the UK that have an unsafe gas appliance. So with those stats in mind, it begs the question, are the methods of CO detection actually regulated by law? The answer being yes, in accordance with BSEN 50291 Part 1 and it must be installed in accordance with BS 5839 Part 6 and a national approved building regulation document. There must be a CO detector installed near any solid fuel burning appliance. All new builds have to be equipped in England, and buildings that are materially altered, such as conversions for extensions or loft conversions, and in Scotland, it is required for all new buildings and existing dwellings. What I'm actually going to do now is play you a short video again from the guys at Hispec, just going over how the CO detection regulations are in place as per BS 5839 Part 6.
Will, take 3.
I normally don't stop talking, so I'm
Scott, take 2.
gonna start stamping.
Will, take 4. 5.
Government advice underscores the critical importance of properly positioning carbon monoxide detectors within living spaces. According to this guidance, the optimal placement for CO detectors is between 1 and 3 metres from potential sources of carbon monoxide.
This recommendation is rooted in the characteristics of carbon monoxide, an odourless and colourless gas that can be emitted by fuel-burning appliances. By situating detectors within this specified range, the likelihood of early detection and timely alerts in the event of CO leaks is significantly enhanced. This strategic placement ensures that the detectors are in close proximity to potential sources, such as gas boilers, fireplaces, or heating systems, allowing for swift response measures to be taken.
Adhering to government advice on CO detector placement is a fundamental aspect of residential safety, aiming to protect occupants from the potential dangers associated with carbon monoxide exposure. Proper placement of carbon monoxide detectors is paramount for ensuring the safety of occupants in residential spaces. It is advised that CO detectors be installed in close proximity to solid fuel burning appliances such as gas boilers or fireplaces, where the potential for CO emissions is higher.
The positioning of detectors near these sources allow for early detection of any dangerous buildup of carbon monoxide, triggering timely alerts and facilitating prompt action. However, an exception to this rule applies to gas cookers. Unlike other gas appliances, CO detectors are not necessarily required in close proximity to gas cookers. This exception recognises that the combustion process during cooking typically produces minimal carbon monoxide emissions, reducing the immediate need for detector placement near gas cookers. This approach to CO detector placement reflects a tailored strategy, ensuring that safety measures are both effective and contextually appropriate for different types of gas appliances within a residential setting.
CO detector placement and humidity concerns. Placement of CO detectors is critical in areas with potential humidity sources like bathrooms. If a boiler is placed in a bathroom, it's advised not to install the carbon monoxide detector inside the bathroom due to high humidity.
This precaution is rooted in the understanding that the internal components of the detector may be susceptible to damage from the elevated humidity levels typically found in bathrooms.
Additionally, placing the CO detector in the bathroom could lead to false alarms due to the atmospheric conditions. Instead, the recommended placement is outside the bathroom door and positioned above the door frame height. This strategic location ensures that the CO detector remains effective in detecting any potential carbon monoxide emissions from the boiler, while mitigating the risk of damage or inaccuracies associated with a high humidity environment within the bathroom.
Close proximity to potential sources allows for swift response measures. Adherence to this guidance is crucial for residential safety and protection from CO exposure dangers.
Prioritising thoughtful and context-specific placement of CO detectors contributes to their optimal functionality and enhances overall safety measures within residential spaces.
So one of the other things we get asked for regularly when specifying carbon monoxide protection in properties is the ability to utilise technology to enhance protection from carbon monoxide. As there's more and more a move away from just an alarm going off if it senses carbon monoxide to a deeper understanding of what's happening with the alarm itself and what's happening with the property. Our BC10 sealed battery carbon monoxide alarm does have that facility where you can extract the data from the alarm itself to give yourself information such as the sensor health, the battery life, the operational duration, how many times that alarm's been deactivated, when there's been peak CO levels in the property, the current ambient CO level, and how many times that's been tested, which is great for the social housing market where the engineers are going in and testing alarms as they can extract this data and save that in a report format for the yearly tests, so they can actually monitor quite easily what is going on within that property. So I would just like to say thank you very much to you all for taking the time on a Friday afternoon to listen to me and to attend this training. As said before, it does qualify you for CPD points, which we'll send via the via CAT. And we will now go to the chat window and look at any questions. Thank you.